already listened to the theory videos about energy transfers, efficiency and power, or you're already confident that you understand what those ideas are. Exam questions can either be theory or they asking for written explanations, or in this topic quite often they are calculations. So I've just, on the left here, you've got a sort of section of the equation sheet that is on the trilogy paper or combined. On the right is if you're doing separates. The two equation sheets are very similar, basically different titles and a couple of extra in the separates one. So the equations you need for this topic are all at the start of the equation sheet on the front of it. Please always be aware it does have a back as well, but for this topic, you're just looking at these first sort of 8 equations. The key thing that trips people up here is not understanding that energy transferred and power are the same thing. So I could be given a kinetic energy or calculate a kinetic energy using this top equation here, and then I could substitute that value in for either energy transferred or work done in one of these power equations, or, you know, if I'm driving a car, kinetic is my useful output, and that could go into an efficiency calculation. Same with gravitational potential and elastic potential energy. They can go into any of these equations at the bottom, and so can change in thermal energy. Or I could have to use one of these equations to come up with an energy transferred, a work done, or a useful output, and that could then go in for change in thermal energy, gravitational potential energy, elastic potential energy, or kinetic energy. So have the confidence to sort of mix these equations up. If it says energy, or it says work done, or it's measured in joules, it can go in any of these places where it mentions a type of energy or work done. Power and efficiency are something different. Okay, so I'll look at a couple of examples of exam questions of varying difficulty, some wordy ones and some calculation ones. So exam questions, as you will probably have noticed, often start with a bit of a situation. So the photograph shows a toaster. The toaster is connected to the main supply using a 3-coil cable, which means it's plugged in. You don't have to know anything about the mains for these exams, but often exam questions test some information from one bit of the course and then go on to test something from another bit. So I'm just going to look at some sub-questions here. So part D of this question, complete the sentences, choose answers from the box. We've got chemical, should really be chemical potential. You've got elastic potential, kinetic and thermal. When bread is lowered into the toaster, a spring is stretched. The stretch spring stores what kind of energy? So stretching a spring, we should know that that is elastic potential, so that goes in there. After the bread is toasted, the spring makes the toast move upwards. As the speed of the toast increases, the something increases. So speed increases, that's movement, so that's kinetic. Now, this question is a little bit confusing because it talks about the toast moving upwards, and that would be gravitational potential. So in this case, as the toast moves upwards, it gains both gravitational potential and kinetic. You've got to choose the best fit answer from the options, and because it's talked about speed just before this gap, kinetic is what they're looking for. We've then got a calculation question. The toast was moved upwards by the spring. The change in gravitational potential energy of the toast was 0.049. Now, sometimes people get confused by the fact it says change here. Some of the equations on your equation sheet mention changes, some of them don't. If you've got a change in energy, you can use that as an amount of energy. So we're going to pick this equation here, gravitational potential energy. We're going to put change in gravitational potential in for gravitational potential. It asks us to calculate the change in height. We're going to calculate the height, and that's our change in height. Okay, so this is where the language can be a little bit confusing. So our toast is moved upwards by the spring. The change in gravitational potential energy of the toast was 0.049. So I write out the equation either in words, as on the left, or in symbols, as is on the right. But if you use symbols, you must use their symbols. So EP for gravitational potential energy, M for mass, G for gravitational field strength, H for height. So I substitute in, where it says gravitational potential energy, I write my 0.049. Then we've got an equals in both. Mass, 0.050 kilograms. Okay, that goes in. Gravitational field strength is 9.8. And then times height, we don't have a number for, so we just write height or small h. First thing I'm going to do is simplify. So I've got these two numbers, 0.05 and 9.8, that I just times together. I get 0.49. So 0.049 equals 0.49 times h. Even if you go on to rearrange that incorrectly later, you will still get a mark for one of these two top lines, so substituting the numbers in. So always do that before you rearrange. Okay. Now when you're rearranging, things move. The thing that is on its own on the left-hand side, so this 0.049 on the left-hand side, that is on its own and it stays on the top of the division. This thing on the right-hand side is moving diagonally from the top of the right-hand side to the bottom of the left-hand side. Okay, so 0.049 on the top, 0.49 on the bottom. I get a change in height of 0.1 meters. Now, if I'm not super confident with rearranging equations, I don't find that easy, there's a couple of ways I can check. Okay, the thing I would do that always works is go back and put that 0.1 in here. So I type into my calculator 0.050 times 9.8 times 0.1 and check I get 0.049. If I don't, I've rearranged it wrong. If I do, I know I've rearranged it correctly. The other thing that works often is common sense checking it. 0.1 meters is about 10 centimeters. That's the sort of movement of the toast from the very bottom to the top of the toaster. That's a sensible answer. If I'd rearranged it incorrectly and I'd got 10 meters, okay, 10 meters is higher than a house. That's not how far you expect your toaster to send your bread or toast. Okay, another exam question. Diagram below shows a girl skateboarding on a semicircular ramp. There is a 4 meters on the side. It did ask you to do some calculations with that in the exam. The other numbers were in the text. So sometimes people get stuck on calculations because they think I need a number for this and I haven't got it. Often looking back at the very beginning of the question, it's on a diagram or it's in the text at the very beginning of the question, or it's a number you've already calculated in an earlier part. So just watch out for that. Not all of the GPE, gravitational potential energy, has been transferred to kinetic energy, which 2 statements explain why. Tick 2 boxes. So it's really sad when people lose a mark because they only tick 1. So some energy is wasted. That's sensible. We know some energy is always wasted. The mass of the girl is too low. That the amount of mass doesn't affect the transfer of energy. Okay, it affects how much energy you've got going from one pot to another, but it doesn't matter for efficiency or energy being transferred. The ramp is not high enough. Again, that's the setup. It doesn't affect the energy transfers within the setup. The GPE is not 0. The speed of the girl is too great. So the second correct one is this: the GPE of the girl is not 0. Okay, you can see on the diagram she doesn't go all the way to the bottom of the ramp. She's still got some height at the bottom when she has most kinetic energy. She's still will have some gravitational potential energy. So she's got gravitational potential energy. As she goes downhill, she loses it and gains kinetic energy. As she goes back up, the opposite will happen. So some energy is wasted due to friction as she skateboards, and she doesn't get all the way to the bottom, so her GPE won't reduce to 0 completely. Okay, so not all of the GPE has been transferred to kinetic energy, because some is wasted and the GPE is not 0. Next question, explain how lubricating the wheels of the skateboard can increase the speed of the girl. Okay, so a couple of marking points, you can see it's 3 marks. 1, lubricating the wheels, so that means putting some oil inside the bearing, something like that. That will reduce friction, okay? So that means less work is done against friction, which will be 1 mark. Less energy is transferred to a thermal store in the surroundings. In other words, the wheels get less hot. That's your 2nd mark. Your 3rd mark, it says can increase the speed. I need to link that to my ideas about energy. That means more energy is transferred to a kinetic store. Another exam question. Image shows a girl riding a self-balancing scooter. It's just making sure we all know what a scooter is when it mentions it later in the question. The table gives data for 2 scooters with different motors. Both motors have the same efficiency. The same efficiency just means we can compare them. Okay, we can make a valid comparison. It's a fair test. That's a control variable. Then it says power. So we are immediately thinking power means how quickly it transfers energy or how quickly it does work. Explain why scooter B has a higher maximum speed. You can see it's got a higher power. Okay, I would be showing that I know what power means, the energy transferred per second. So scooter B has a higher power, therefore it's going to be transferring more energy each second. Okay, and because the scooter's moving, it's transferring 2 kinetic energy. So more kinetic energy each second. Okay, and I would recommend you pause the video and have a go at actually writing an answer to this and the previous question as well. Listening to and understanding it is not the same as being able to write the answer yourself. And I deliberately haven't given you a written answer for that reason. You might need to rewind to help you, and that's fine. Both scooters can be ridden for 20 minutes before the battery needs recharging. Compare the amount of chemical energy stored in the battery of each scooter. So compare the amount, say which one has most chemical energy. And it will be scooter B, it has a higher power. Question doesn't ask you to explain, but because they're both being ridden for the same amount of time, scooter B has a higher power. It's transferring more energy each second or each minute, therefore it needs more chemical energy.